Hello everyone, welcome to this brief introduction to NinoLearn, a research framework for statistical ENSO prediction that I recently developed during my master thesis at the University of Utrecht. Today I'm very happy to share with you the core idea behind NinoLearn. So what is NinoLearn? NinoLearn is a Python 3 package that you can download on GitHub, and there are as well some documentations for the package, as well tutorials available online. So if you watch this video, you are probably already somewhat familiar with the El Niño Southern Oscillation. So therefore just a short recap now on that one. It is this recurrent warming and cooling event that takes place in the tropical Pacific. So for instance, in this video you see the sea surface temperature anomaly in 2015, when one of the strongest El Niños of the recent decades took place. To quantify the El Niño Southern Oscillation, one usually defines indices. So these indices are averages of the sea surface temperature anomaly in certain regions of the Pacific. And the most commonly region that is used for the prediction of the El Niño Southern Oscillation is the so-called Niño 3.4 region, which is here shown with this dotted box. So if we compute the 3-month running mean of the sea surface temperature anomaly average of this region, we get this time series. So here you see those reoccurring warming and cooling events, and note that about every 15 years we see a very strong El Niño taking place. So such an event, for instance, happened in 2015, 2016, as well as in the late 90s or in the early 80s. So if one wants to develop a new statistical model for the prediction of the ENSO, so the prediction of one of these indices, so for instance the Oceanic Niño Index, there are several steps involved in the build-up of the research. So at first people download data, then people pre-process this data using, for instance, empirical orthogonal function. Then they actually can use this pre-processed data to build a statistical model that then can be evaluated by making some hindcasts that can be compared to previous observations. The problem with this entire process is that every researcher writes his own code for the entire process, although there's a lot of repetition involved in it. So a lot of people download the same data, or a lot of people pre-process the data in the same way before they build their models. And that's why I developed NinoLearn. So NinoLearn is a GitHub repository now where people can share their codes which they use for the prediction of the ENSO. So if one researcher already wrote a script that downloads automatically all ENSO reanalysis or data from another data set, then other researchers simply can use this code. And the same accounts for pre-processing procedures, or if another researcher is maybe just interested in reproducing the research of someone else. So to summarize, NinoLearn was developed to speed up the research because it avoids that people write similar codes again and again. Furthermore, it makes the research more transparent, comparable, and reproducible. And last but not least, it facilitates a collaboration between different researchers regarding the work on ENSO prediction. So for instance, we now developed a first model within NinoLearn. This model is called Deep Ensemble and was recently published by a few researchers from Google DeepMind. Instead of just predicting one value, as it is typical for the prediction of the ENSO by statistical models, this model actually predicts a Gaussian distribution. So hence it predicts a mean and a standard deviation. And so the prediction of the model comes with the estimation of the predictive uncertainty, which is a new feature for the prediction of the El Niño Southern Oscillation. And with a NinoLearn, one now can evaluate this model. So for instance, one can evaluate the model onto its prediction skill in different decades. So here you can see, for instance, the evaluation using the Pearson correlation coefficient. And for a few decades, actually, the model is performing very good for predictions for very long lead time. So this is this you can see, for instance, with this green or brownish line, for which the correlation coefficient stays relatively high. So with the correlation coefficient of R about 0.8 for very long lead times. However, in other decades, the model is actually performing worse. So with a NinoLearn, we also can evaluate the model onto its seasonal variability of prediction skill. And here you can see that for some seasons, the model has a very high prediction skill. So that is, for instance, for winter seasons, and for other seasons, the prediction skill is worse. So for the spring period, the correlation coefficient between the observed and the predicted mean, in this case, of the oceanic Nino index is relatively low, here seen with this bluish area in the middle of the plot. So thanks for your attention, and here are again the links to the GitHub repository as well as the documentation. And I would be very happy if one of you would get involved and work on NinoLearn and develop it further. And yes, thanks for your attention.